Okay, so we're here. So we isolated the one of the radicals, square root of x plus 5. Then we squared both sides, which can be seen right here, so that we can undo this radical here. So we're just left with x plus 5.
Wait. Question.
Okay. Over here, I'm going to do it the long way. I'm going to do it the long way so that I don't make a mistake. So I would have x plus 5 is equal to, first, 2 times 2, 4 plus 2 times root x minus 3 is just 2 root x minus 3, plus this times 2 is 2 root x minus 3, plus square root x minus 3 times the square root of x minus 3 is just x minus 3. You don't have to write in parentheses, I'm just showing you that they're associated with one another. Dropping parentheses doesn't affect anything.
Hey.
Yes.
The 4, again, where you get the 4 from, yeah, this way it's going to say. And then, what is this? Oh, never mind, it's 2. Where does the extra x minus 2 come from?
Extra what?
X minus 2.
So FOIL is the first terms are being multiplied, 2 times 2 is 4. The outside terms are being multiplied, 2 times the square root of x minus 3. The inside terms are being multiplied, square root of x minus 3 times 2. And then the last terms are being multiplied. The square root of x minus 3 times the square root of x minus 3 is just x minus 3. So if you're still not 100% certain about that, I'm not sure if we discussed it or not, but this is just a basic principle. This is just an example. I'll erase it in a second. This here, I think we've discussed it before, I'm not sure.
3 times, yeah.
Okay, thank you. Right? Okay, that's what this principle is here.
So by just multiplying them, both the radicals by themselves is like square root. Basically, because you get rid of square root.
I can't see this one.
Yes.
I can't see.
So then we're just going to continue. It's going to go, just go ahead and simplify this some more. So we're going to have x plus 5. The right hand side simplifies. I have 2 of this plus 2 more of the same thing, right? This is a good fundamental thing to keep in mind, that if I have 2 of something plus 2 of the same something, it's just 4 of that something. It doesn't matter how complicated it may look. Right? It doesn't matter how complicated this may look. The fact that it's a radical, it doesn't affect it. Right? The fact is that they are the same, so I would have 4 of that something. 4 of these. Okay? So there's some like terms here. I see that there's a constant here, and there's a constant at -3 here. I'm going to combine those, and there's also an x left over. So we still have plus x plus 1.
Wait. Yeah, I see that.
Yeah, but I hear a lot of weights. Raise your hand if you have yes.
I see where we got it from. I see where we got it. Okay. After the root of x minus 3, where do you get the plus x plus 1?
Okay. That is, the x is here.
Yeah.
And then when I combine the, what's circled in purple, the 4 and the -3, that's 1. So I'm just simplifying the right hand side.
Okay.
Yeah, you can drop the parentheses. The parentheses doesn't affect anything.
Yeah, because I was like, wait a minute. So you just did the 4 minus 0.
Thank you. So we continue this. I'm going to have x plus 5 is equal to, I'm just going to write the same thing over here. All right, Maya had the right idea of, okay, now we want to isolate this radical. So this is where you repeat the process, right? We started out with a double radical equation. Now we're down to a single radical, but now we're going to isolate this radical. There's only one left. We're going to isolate this guy. To do that, we're going to subtract x and subtract 1 from each side. Doing this yields 4 equals 4 root x minus 3.
We said
So
that if you were
it may be a review for some of you that actually did all the homework. And then now here I could square both sides as it is now, but I want you to see that it would be convenient to divide both sides by 4 here. Perfectly allowed to multiply or divide both sides of the equation by a non-zero constant to have an equivalent equation. But I could square this right now. I could say, now here's the question I had for last class, see if you guys understand this. What would this whole right-hand side be if I squared it?
If you got long
16 times parentheses x minus 3. Okay, that's a very basic principle that we can't forget. I'm asking you basically if I had some product raised to the second power, this would be equal to a squared b squared.
Yes.
Let's not forget this when we have a product.
Oh, wait a minute.
So I'm gonna go ahead and divide by 4 because it's convenient. So I divide this by 4. I divide this by 4. I would have 1 equals the square root of x minus 3. And now here I'm going to square both sides because I've isolated it was isolated here too, just had a 4 in front of it, but it's isolated here completely. I have 1 equals x minus 3, then adding 3 to both sides, x equals 4. And now I need to test this guy. Please stop with the noises. Please. Testing x equals 4. That's being plugged into the original equation. So I have the square root of 4 plus 5 minus the square root of 4 minus 3. And we're saying that this equals 2. So I have the square root of 9 minus the square root of 1. This is just the principal root, of course. So the square root of 9 is 3. The square root of 1 is 1. So I get a statement that is a true identity, so 2 equals 2. So this, in fact, is completely true. It's definitely a solution.
Okay, so the part that always confuses me is that when you have the square root and you have the 2 or whatever is there, and it's plus or minus, then whenever you square root it, you have the square root. You have to FOIL the 2 and the square root, and I would just end up FOILing the square root, or just end up FOILing what was in the square root.
Yeah, so FOIL stands specifically for first, outside, inside, left. That's when you're multiplying 2 binomials.
Okay.
Are you okay? Do you have a question?
Oh, no, I was saying because like normally what I end up doing, I end up only boiling the actual x minus 3. I don't actually boil the whole thing, and that's what I'm saying. So whenever it's a 2 plus, minus, or whatever it is, then you would boil the entire right-hand side, not just the x minus 3.
Yeah, if I raise the left-hand side of the equation to a certain power, I have to raise the entire right-hand side to that same power. You cannot just decide, oh, I'm going to raise just this term over here. You have to raise the whole, entire both sides to a certain power.